This is another example, and this is an important one to pay attention to because there is one step that we didn't do in the previous examples that we must do in this example. We're still going to solve. Algebraically. I'm going to rewrite this inequality as negative 4x plus 30 is greater than or equal to 5. The reason I'm doing that is because I like my x to come first in my inequality. You'll notice this symbol stayed with this coefficient and variable pair. And even though it's not marked, we know that this is a positive 30, and this stayed positive 30. So all I did was flip-flop the terms, but nothing changed in the equation except their order. The value did not change. So now we have x multiplied by negative 4 to get negative 4x plus 30, and that's greater than 5. Now to undo these steps, instead of adding 30, we subtract 30. 5 minus 30 now becomes negative 25. And our last step is to divide. We're going to divide by negative 4. And negative 25 divided by negative 4 is 6.25. So negative divided by negative turns to a positive. Our solution is where we are going to need to pay attention. Whenever this last step involves dividing or multiplying by a negative, we must flip the inequality sign. So a reminder, in the original inequality we had a greater than or equal to. X was greater than or equal to. We now have to make it less than or equal to. And then the solution we solved for was 6.25. Let's test it out. Let's choose a number that's less than 6.25. My favorite number to test is always 0. So we do negative 4 times 0 plus 30. Is that greater than or equal to 5? We're testing it out in the original equation. And in fact, 0 plus 30 is indeed greater than 5. Had we not switched our sign and tried x is greater than 6.25, like let's try 10, so negative 4 times 10 plus 30 more, is that greater than or equal to 6.25? We would have gotten negative 10 is greater than 6.25, and that is not true. This is not true. So switching our sign allows us to get an accurate solution that will work in the context of our inequality. So this example shows us that when we divide or multiply as our last solution step, when we divide or multiply by a negative number, when this number is negative, we must flip the inequality symbol. So in our original problem, it was greater than. In our solution, it's less than. Greater than or equal to switches to less than or equal to.